but you're right. All right.
Shit. What was it talking about? Oh, okay. Well, so of course, sine squared plus cosine squared is what? 1. Notice then that sine squared is 1 minus cosine squared. So then sine is the square root of 1 minus cosine squared. Right? Ooh, it's amazing, Jeff. Wow, you just opened my eyes, right? And this would be plus or minus, but don't worry about that shit at the moment. Okay? If I just said, all right, let's just pretend, let's say that that's something, I don't know what cosine is, so let me just call it x. Isn't that what's on the bottom of the sine derivative? I'm trying to show you a way to remember which way those go. 1 minus x squared is related to 1 minus sine squared. That would be the true trig identity for that, right? Now, what's the identity for tangents and secants? What's that identity? Tangent squared, secant squared. How does that identity work? Okay, if I take this one and I divide by cosine squared, right? If I divide by cosine squared, what do I get? Sine over cosine is, so I get tangent squared plus 1 equals secant squared. Okay, that's another identity you should know. But like I said, you actually can build identities off other identities, and this is the most fundamental building block, is this dude, right? How are we doing so far? So then isn't tangent squared equal to secant squared minus 1? And do you see how, so tangent is equal to square root of secant squared minus 1? And isn't on the bottom of secant's inverse derivative square root of x squared minus 1? No, I'm trying to show you a way to memorize this shit. Some of you guys are like, I just repeated to myself 80 billion times. Okay, that's fine, whatever. I always try to relate it to stuff that I know about it already. So it's less memorization and just building off of stuff I already know. So I don't know if this is, does anybody see what I'm trying to do with this? I'm trying to give you a way to remember these based off of their identities that you're supposed to know already anyway. All right. And of course, if I know secants, cosecant's inverse trig derivative is the negative of that one, right? All the cos shit is negative still. That's awesome. And tangent's the one little oddball. Right. Yes?
Just on the format of the test, for the trig identities without a calculator part, are we going to be doing that part first and then turning it in, or are we going to get it all at the same time and it's, hey, don't use your calculator on this part?
Oh, yeah. So the way it's going to work, if it is 2 parts, the first part will be the not calculator, and then when you turn that in, you can take your calculator out and use it on the next part. Yeah. Some of you guys might have picked up on the fact that that means I haven't made the test yet. But that's not quite right. I have 2 possibilities from past times I've taught this. One time I had a calculator part, and the other time I didn't. I'm just trying to figure out which way I want to go with it. You know, like, let me find somebody who took that. Remember, there are many versions of the test itself, so let's get lucky twice over. Again, I got nothing. I love how you're looking at me. Bum, bum, bum. I want to see how long this can go for.
Stare into your souls. I looked into his soul. I tell you, he was a good man. You watching the World Cup? Yeah, I'm not. Sorry. Who's your favorite? Well, there you go. Okay. Huh?
Brazil, bro.
Brazil? Okay. Look, we're out of it, aren't we? We weren't even in it to begin with. Is that right? I'm sorry if that still stings somebody.
For the practice test, would you mind going over 13B?
Oh, okay. So I sort of got lazy and stopped showing you all the steps, but the first step on 13B is to do what? Is it written in a good format? No. So the first step is to rewrite the rational stuff, the radical stuff as exponent form, right? Because then it can apply the 3/4. Yeah. And this will be x to the negative 2/5. If anyone has any trouble with this, roots on plants are on the bottom most of the time. Any botanists out there, don't come in. Tubers are actually screwed. Roots are on the bottom of most plants. So the fourth root becomes a 4 on the bottom. Right? I mean, okay. If you have any problem with that, because it sucks if you rewrite it wrong, you ain't got a chance to get it right. Right? But again, if you did rewrite it wrong and you did everything else correct, you're only going to lose points that one time. Just for that first mistake, right? So now you just apply the power rule. All right, so that's why this becomes 3/4 x to the 3 minus 4 is -1. And then negative 2/5 comes down, so it becomes positive 4/5. Negative 2 minus 5 is -7. Which is hopefully what I wrote down. Yes?
For something like part F, if we like see something that you did where you can just factor it out, can we do that on the
Of course. I wanted to show the way that I thought most of you guys might have done that problem, and then I wanted to show, hey, shit, we could have gotten there a lot quicker. So I sort of do that on, like obviously J, we all know that, to look for that. If the power's on the inside thing, I can take that out in front of the natural log. I can't do that on part L though, right? You're gonna love that there's a part L. But yeah, if you would have done 13F factored and canceled and then did a derivative, beautiful. Kicks ass. That's what I hope you would do. If there's a way to make it easier for yourself, oh yes, do it.
For problems like that, do you want us to, can we leave it like that, or do you want us to put it back into the root form?
It really doesn't matter. I can't remember if I said this in this class, but I hate that we have root notation in the first place. But if you like it better, you can put it back in root notation. Doesn't matter. They both mean the same thing, which is why we don't need both of them. This is better. In a lot of different ways, it's better. But oh well. We weren't around when they were doing shit, so they would have probably shot us just to make it easier. I don't like that. All right, everybody's in agreement? Okay, moving on. This guy can handle all this.
So anytime we have a problem, we see a problem with the root, would you recommend just rewriting it that way?
That kicks ass. Do it again.
So anytime we come across a problem that has a root, would you recommend we just rewrite it that way?
Yeah, if you're going to take a derivative, the rule is written in terms of powers.
Okay.
Now, we could take the time and figure out a rule for rational form, but radical form, I mean, right? But why would we do that? We can always just make them a power and use that one rule for everything. Yeah. I don't know if I knew this. Ooh, I like it. Anyway, sorry. So, I'm sorry. So Desmos can handle some. Remember, there's functions in here in like 3.5. Did you guys see all the cool graphs of like spirograph stuff? Right? When you have functions you can't solve for y, they can just twist and turn on themselves. They look like spirograph stuff every now and again. Or they look like, either you call it the heart graph or the butt graph, depending on how you feel. This poor little cardioid dude up here. Desmos can handle that shit. That's awesome. I don't know if I knew that. I just found one it couldn't handle, but yeah. Anyway, you can plug some of this stuff in and see what it looks like. The ones that they don't give you graphs for, like the Campbell of Eudoxus. Euda what, Jeff? Or let's see what's more interesting. Anyway, I'm going to tell you. You can actually plot it in Desmos and see what it looks like, all twisty curvy. It's kind of nifty. Oh, I didn't tell you guys. You guys know about Wolfram Alpha too, right? I know about it too. If you pay some money, you can actually put a problem in, have it solve it for you. It'll tell you all the steps. It's insane. It's just that students sometimes use that to do their homework with, and sometimes it does things in a very weird way. It makes it very easy to pick up on. But at the same time, it kicks ass for a study guide, study tool. Put some shit in, you say take the derivative of this, and it tells you every step what to do. It's crazy. It's kind of amazing what they've done with that thing. Math is 1% of what Wolfram Alpha does, by the way, if you know about it. It does chemistry, history, it does biology, it does, oh my God, economy, it does, oh my God. Type in your last name, it'll tell you statistics about people who have that last name and what percentage, and when was it most popular. Oh, it's insane. How old was Albert Einstein when the first hydrogen bomb, how old would he have been and when the first hydrogen bomb went on, whatever. It's insane. How many angels can you fit on the head of a pin? You can type that in there and it'll give you an answer. Not a numerical answer, but. Sorry, I tend to go off on tangents when I.
Does it do, what is the meaning of life?
Yes,
42?
yeah, yes, it'll do that. It actually gives you a couple options. It says the Hitchhiker's Guide option is 42. Yeah. And you say, what's the question? That's more interesting. Have you gotten to that point yet? The question is, what is 6 times 9? So think about that. That's like in a later book in the series. Yeah. I don't know if you guys believe me. I have nothing. So if we're done asking questions, you don't have to sit here. But otherwise, we can keep going if you think you do have more questions. I just remind you guys, if you're somebody that wants to ask, you don't want to ask in front of other people, I am in my office right before class for an hour. Oh yeah.
Was I not supposed to make tables?
Yeah, on, I think, no, let me see. Yeah, so for that one, if you look at examples where they figure out what's happening without using a table, right? Like the limit as x goes to 3 from above is positive infinity because you're always going to be getting a positive number on the bottom. Do you see what I mean? So I'd rather you figure it out not using a table, but just using your reasoning about what's inside. So like, this one's fine, I just wasn't sure about where that came from. This one you have to think about, as you go to 1, from either side, the bottom is positive and the top will be positive. When you get really close to 1, the top will just become 1. So that's why it's positive infinity. I don't need to do any of this stuff. I know it's going to be some kind of infinity, right? Because the bottom's going to 0. But the real question then is it positive infinity or negative infinity? And there should be another way to determine that without needing a table.
Okay.
So on one level, I'm okay with the fact that you're like, I don't know what that is, let me look at a table. There's nothing wrong with that instinct, but these infinite limits, you really do need to figure out how to look at them without a table. Like, you need to know what ln looks like, so you know it's going to be negative infinity, right? Since that's inside's going to 0, it's going to be negative infinity because of what ln looks like. Like that negative infinity asymptote thing. Yeah. Okay. Is that cool? Okay. Sure.
I do have a question.
Yeah.
For 3.1 number